Good morning, students. Myself, Dr. Board from Shakti Vidya Niketan Mara. During the last lecture of General Science, we have completed our second chapter of your syllabus. From today, we are going to learn the chapter number 3. The name of the chapter is Properties of Natural Resources. Okay, this is your third chapter. Okay, so before we are going to start this lecture, first we recall that chapter from the last year, means the natural resources, air, water and land. Okay, now you know that in 6th standard you have studied the different natural resources like air, then water and land. Okay, these form the different spheres of the earth, namely the natural resource air, it forms atmosphere, water forms hydrosphere and soil forms lithosphere. Okay, these are the three spheres of the earth. Okay, during this year we will study the different properties of natural resources. Okay, before that I will ask you some questions which are given on page number 16. Okay, which are based on the lesson that you have studied during last year. Okay, first question: which are the gases present in air and why is air called as a homogeneous mixture? Okay, so which are the gases present in air? During last year we have studied this. Okay, so oxygen, carbon dioxide, nitrogen. Then inert gases contains helium, lithium, beryllium, neon, argon, krypton, xenon. Okay, so these are the different gases which are present in the air. Okay, so many gases are found in the air, and the next question is that why is air called a homogeneous mixture? Now there are two terms, homogeneous and second one is heterogeneous. Now first you should understand what is meant by homogeneous mixture and what is meant by heterogeneous mixture. Okay, so homogeneous mixture means what? Now you know that every matter having three states. Okay, all the matters which are present in the universe, they are present in the three states. Either it is in solid state, or it is in liquid state, or it is in gaseous state. Okay, so solid, liquid and gas, these are the three states of matter. Okay, so when you consider the air, now you know that what is the composition of air? Air consists of different gases. Okay, so homogeneous mixture means what? In the air all the gases are present, means gas plus gas. Okay, so for example in the air oxygen is present. So oxygen is one gas and other gas, for example helium is there. Helium is also a gas. So it is also a gas. So both the contents which are present in air are in the gaseous form. Carbon dioxide is also in gaseous form. Nitrogen is also in gaseous form. Okay. So all the constituents which are present in the air are in the same state of matter, that is gas. Therefore it is called as homogeneous mixture. For example, when we add water in milk, it is also homogeneous mixture. For example, water plus milk. Okay, water is present in which form? It is present in liquid form. Okay, and milk is also in liquid form. Okay, so in this case also liquid is mixed in the liquid or the liquid. Therefore it is also homogeneous mixture. Understand? Means when we add one state of matter in the same state of matter, means gas plus gas, or liquid plus liquid, or solid plus solid. Okay, so both the constituents, when these are present in the same state of matter, that mixture is called as homogeneous mixture. Okay, and second type of mixture is called as heterogeneous mixture. In that, for example, now you know that in cold drinks there is liquid plus gaseous form. Okay, so you have seen the effervescence which are present in the top of the bottle because of two different state of matter are present in the cold drinks. So liquid means cold drink is in liquid form, but it also consists of carbon dioxide inside it. Okay, so this is also liquid plus gaseous form, so it is called as heterogeneous mixture because the states of matter which are mixed together, they are different. One is liquid form, second one is gaseous form. Therefore, it is called as heterogeneous mixture. Understand? Means in homogeneous mixture, two same states of matter are mixed with each other, and in heterogeneous mixture, two different states of matter are mixed with each other. Okay, understand? So air is the homogeneous mixture, or it is homogeneous. Okay, because in air the different constituents which are mixed, they are same state of matter. Means all the constituents which are present in air, they are in gaseous form. Okay, so therefore air is called as homogeneous mixture because the constituents which are mixed together, they are of same state of matter. Okay, so second question, what are the uses of the various gases in air? Now during last year you studied the different uses of the gases. For example, what is the use of oxygen? Oxygen is useful for the respiration process in all living organisms. Okay, then carbon dioxide is used in fire extinguishers. Okay, you know that. And carbon dioxide is also used for photosynthesis process in plants. Okay, so these are the different uses of gases. For example, argon is used in electric bulb. Okay, so these are the different uses of the different constituents or gases in air. Okay, now the next point, properties of air. Now you know that natural resources are of three types, which are air, then water and land. Okay, so in land is made up of soil. Okay, so in this chapter we will learn the properties of air, properties of water and properties of land. Okay, so first we will study the properties of air. Okay, now air is present all around us. You know that in the atmosphere everywhere we will find the air. We cannot see, we are not able to see the air, but we can feel the presence of air. For example, when there is a cold breeze, at that time we feel cold, means we can easily feel the presence of air in the atmosphere. Okay, when we inhale, air is taken in through the nose. When we inhale, during the respiration, the air from the outside it goes inside through the nostrils of our nose. Okay, and when we blow on our hand through the lips, for example, when we blow our hand from our lips, then we will feel the air on the palm of the hand. Understand? Now one activity is there. From that we will study the first property of air. Now what we have to do? Take a stick from a broom or a paper or plastic straw. First you take the plastic straw like this. Then you tie two balloons here. Okay, first balloon and here second balloon. But in the second balloon you blow it from your mouth so that the balloon becomes inflated. Okay, this is inflated balloon. Okay, means you put the air inside with the help of mouth. Okay, so take a balloon. Okay, inflated balloon. So what will happen when you tie the inflated balloon toward the one end and second one is not inflated balloon? Okay, then you have seen the position of straw is like this. Okay, so the end of the inflated balloon goes downside. Okay, what is the conclusion of this activity? So why this inflated balloon goes downside? Because the air which is present inside that balloon is having weight. Okay, it having weight as well as mass. Okay, so this is the first property of air, that air consists of weight and mass. So this is the first property. Air consists of weight and mass. As you know that the solid state of matter, the solid also having weight and mass, liquid also having weight and mass, like that air also consists of weight and mass. From this activity we conclude that the air having weight and mass, because the straw which having the inflated balloon, that air goes downside when we inflate it. Okay, so the stick goes down on the side of the inflated balloon. This means that air have weight. Air is a mixture of gases, therefore like all the matter, it also having mass and weight. Okay, now second activity. Now you have seen the injection syringe. Okay, so in second activity, what we have to do? First you take the injection syringe. Okay, and it is without needle. Okay, for example, now when you draw the diagram of the injection syringe, it is also given in the textbook. Okay, so it having piston from back side. Okay, here there is a marking. Okay, so for example, this is a syringe of injection. Without injection, you take that syringe, and here is a piston. Okay, so you know that in the injection syringe there is a piston from back side, and we pull it back, and then the liquid which goes inside in that syringe. Okay, like this. So take an injection syringe without a needle. So here is no needle. So you take that syringe without the needle. Pull the piston and observe it as you do so. So you pull that piston back side. Okay, and what do you observe? The piston can be pulled out easily. Okay, so you can easily pull that piston without more force. Okay, so you can easily pull that piston. The piston then remains. The piston then remains in that position even if you let it go. For example, when you pull that piston and then release, that piston remains as it is for more time. Okay, this is the first activity. After that, now close the inlet hole of the syringe tightly with your thumb. Now in second case, what you have to do? You keep the finger or the thumb toward this mouth. You keep the finger here. Okay, on the mouth. Then pull the piston and let it go. What will happen? If the force required to pull out the piston more or less, obviously when we keep the finger over the hole, at that time you can easily pull out the piston. Okay, so why it is so? Because if the force required to pull out the piston more or less, it is obviously less, because the outside air does not enter inside the syringe after you close the mouth of the piston. Okay, so therefore the air from outside will not go inside the syringe and you can more easily pull the piston. Okay, the molecules of the gases in the air are in constant motion. Now all the molecules which are present in the air are in constant motion. That motion is called as random motion. Okay, means for example there is one beaker. Okay, inside that there are small molecules of air, empty beaker, but we are not able to see the molecules of the air. But these molecules are continuously goes upside, downside, or any direction. Okay, so these molecules constantly move from one place to another place. So this is called as motion of the air molecule, but it is called as random motion. Okay, so the molecules of the air are continuously move from one place to another place. It is called as random motion of the air. So when these molecules strike the body, that creates the pressure on the body. This pressure of air that we call atmospheric pressure. When we keep the thumb over the mouth of the syringe and then we pull the piston of that syringe, what will happen? We feel the pressure on the surface of the thumb. Okay, so when we keep the finger on the mouth or tip of the mouth of the syringe and when we pull the piston, at that time we feel the pressure on the surface of our thumb. Understand? So this is called as atmospheric pressure because this pressure is created by the air molecules which are present inside the syringe. So we feel the pressure. That pressure is called as atmospheric pressure because air is present in the atmosphere and that pressure is created by the air. Therefore, the pressure is called as atmospheric pressure. Okay. On pulling the piston with the inlet hole of the syringe closed, more space become available to the air in the syringe and it becomes rarefied. As a result, the pressure of the air in the syringe is lowered. So at that time when we keep the finger on the tip of the mouth, okay, at that time the pressure inside of the syringe is low because outside air is not enter inside the syringe. Therefore, the inside pressure is low. Okay. Comparatively, the pressure of the outside air is very high. This means that now this is inside air, means the air which is present inside the syringe, and this is called as outside air, means the air which is present outside the syringe. Now the air which is present outside, it have more pressure as compared to air which is present inside. Understand? So outside air having more pressure than inside air. Okay. So outside air having more pressure and inside air having low pressure. Okay. So means which pressure which is present inside and outside, atmospheric pressure. Okay. So the air which is present outside the syringe, it having more atmospheric pressure, and the air which is present inside the syringe, it having less atmospheric pressure. Okay. So this is the second property, that air having atmospheric pressure. Okay. So during this lecture we have studied two important properties of air. First one is air consists of weight and mass, and second one is air having atmospheric pressure. Okay. So remaining properties of air as well as other properties of different natural resources, that is water and land, we will study in the next session. Okay. Thank you.